I guess it's working now, huh?
Yes, we can see you, Nafa.
Okay.
That's perfect.
Okay, good.
Thank you, everyone, for being here. Just allow us a couple more, like a minute more until we get all the guests logged in. Thank you.
Let's grab that bottle of water. You need anything else?
Very well. Thank you, everybody, for joining us today. Today's TRACCS webinar series is hosted by TRACCS and WGD Consulting. We are joining here to talk about cybersecurity for transit systems operators. So first of all, thank you for joining. Hi, Nafa. Good afternoon. How are you?
Good. Yourself? Thank you.
Very good. Nafa Duib is one of our board directors at TRACCS since 2022, since early 2022. And he's joining us here today, hosting the webinar with us.
Thank you, Andrea, and thank you everyone for attending this webinar, one of the many that TRACCS offer every year. And actually, Andrea, have we reminded our audience about the other events coming up?
Oh, we haven't yet. This year, we have plenty of interesting events. TRACCS Rail Day, as you know, is coming up. And if I want to share with you the dates. So we have Rail Day coming up in June 20 and 21st. If you haven't gotten booths or tickets, you can do so by going to traccs.ca/TRD23. Before Rail Day, we have something exciting coming up. It's a Canadian Transit Rail delegation to the Czech Republic. This is exclusive for TRACCS member, and we are organizing Canadian transit agencies to join us in a visit of the Czech Republic, looking to meet with the Ministry of Transport, the Prague Public Transit Company, Pilsen City Transport Company, Ostrava City Transit. And so it's a very exciting opportunity for contractors and maintainers. So we will be providing more information. You can email us. Then this year at Rail Day, we will have the showroom, of course, and we will have demos, but we will also have 2-day conference in 3 rooms. And we're also hosting a cocktail on June 20th in the evening so that we can network, socialize, and establish some partnerships. Now, today, what brings us here is cybersecurity for transit systems operators. So without further ado, we could, Nafa, take it.
Yes. So thank you for all these events, exciting events coming up. And like you said, today we are talking about cybersecurity for transit system. And we are lucky to have Michael Godfrey. Michael is a seasoned professional engineer focused on systems integration, communications, and system engineering in the transit and rail industry. He has provided engineering, design advisory, and implementation service for communications for several large-scale rail and transit projects in North America. In the past, Michael's led the communication engineering team at the TTC and communication system engineering rail and transit teams at the SNC Lavalin. Michael is a PEng, professional engineer of Ontario. He had received a bachelor with honors in physics from the University of Waterloo in 1980. and the Bachelor of Electrical Engineering in Queen's University in 1982. Currently, Michael is the owner and co-principal of WGD Consulting Inc. and is currently working on various capacities on several light rail transit projects across Ontario. So, Michael, it's all yours. Thank you for joining us.
Thank you, Nafa and Andrea. Yeah, so today I'm going to talk about essentially cybersecurity as we apply it to transit projects. The main area we're going to talk about, we'll talk about APTA, which is one of the, the American Public Transportation Association. They've come up with some recommendations. I'm not going to call them standards, but recommendations and how to apply it, because a lot of the organizations were looking at some sort of path of how did they adopt cybersecurity and where they start from. A lot of the APTA recommendations come from NIST, which they're fairly complex in there, but that's where a lot of them come from. So I'll walk through it. This can apply for both existing operational systems and also greenfield, and how we get from a greenfield to the operational state. Just next slide up. Very good.
Okay.
It's a bit about us. I'm not going to go through too much because Nafa appreciate what he's, the introduction then. We're a consulting company, predominantly in systems engineering and system integration, and cybersecurity is part of our whole practice that we implement with all the systems that we're doing. I'm going to go through the slides a bit. We have some people in different parts in Canada. We're working in a couple of projects in Western Canada right now, but predominantly we're based in Ontario. This is our capabilities, but it's going to be more about cyber today than what we as a company do. One of the first slides I want to talk to is the governance structure. Depending on the structure, and again, the owner, do we have a third-party auditor, the maintainer, the operator, the structure between those different parties is very important to come up front at the beginning, because that sets the risk level. So who is ultimately responsible for risk? Because cybersecurity is really about identifying the risk, mitigating risk, and how to respond to risk. So based on that, we can look at it and say, based on the overall governance structure, who's really pushing down the requirements and the risk level that the organization is willing to assume. And when we talk about it, it's also, where does our supplier and vendors sit in that? And also the operator versus on some of these projects, the operator is not necessarily the maintainer of those systems. So coming up initially with the governance structure and the hierarchy is very important within the project, depending on how it's set up, whether it's a greenfield or a existing operational project. The main issue when we talk about cybersecurity, and I want to emphasize the word cyber asset, because everyone thinks of cybersecurity as, looking at hackers, someone getting into the system, but it's protecting your cyber asset. So anything as a cyber asset could be a PLC, it could be your servers, etc. It's understanding what are the cyber assets, what the importance, how you're going to protect them. But when we look at IT versus, let's say, industrial control systems or operational technology, which is really what we're going to talk about today, when we look at the difference, in IT, your confidentiality of that information is very high. You have privacy in those. When it comes to ICS and OT, the confidentiality generally isn't very high. It could be low because we don't have that much confidential information. Whereas the integrity of that information and the availability is very high. And that's generally a lot more important, is where we look at it. And whereas patch management is very important in an IT, let's say, environment, where in the ICS or the OT, it may be very difficult for patching. So when we have like a train control system, or we have some of our safety type systems, the patching, because we're running basically not 24/7, but 16/7 or 27, the patching becomes very difficult at times. So we do other compensating controls. So it's important to understand the environment we're going to work under. APTA itself has a philosophy. When you look at it, you want to prevent, you want to detect, you have to audit. And it's not only knowing who, what, where it happened, but being able to show an audit trail that we're following our policies and procedures. And we can show we're following that, because then we can improve on it if there's some gaps there. And then notification. If something does happen, how do we do disaster recovery? How do we do the mitigation? And who do we notify? Mainly in the agency, might be to outside agencies or to the maintenance team. And then who are the teams that are going to rectify the problems? So what is the response, the incident response to these? So we have notification and response to it. When we talk about APTA, they're looking at defense in depth. Now that's what they're looking at now. The industry is slowly going to what they call zero trust, but I'm going to concentrate more on defense in depth. So really what we're looking to do is we look at our different systems, and it's based on the criticality of those systems. And then we sort of aggregate those and put them to a security zone. So we have our enterprise zone, we might have our operational critical security zone, we have fire life safety, let's say safety critical. When we look at that, we say, okay, what's in each of those zones? Because they're the same sort of criticality, we can keep them in the zone. So we might have different controls, how those systems interact with each other, how they talk to each other, and how you access them, configuration management, all the other controls, versus the way we would handle, let's say, a safety critical, which could be your time of ventilation. It could be part of your signal and train control system. And again, that is dependent on each organization's, how they look at their systems and the criticality of those. And again, APTA gives us guidelines, and based on the project, we have to decide which goes into it. I've worked on a lot of projects. If you look in here, Enterprise has CCTV there, but most of the projects I've worked on lately, we always have CCTV as part of the operational critical system because of the way they're using those systems. And it goes with some of the other ones. So it really depends on how those systems are being used for that specific project or operator. So do we know it? Again, one of the biggest issues, do you really understand your systems, how the different interdependencies of those systems and how they interconnect? An example is we have, let's say, electrical meters that we need to gather the data for performance report, metric reports, etc. But those meters are sitting within, let's say, our traction power substations, and now they're being connected up. So how do we do that securely and understand there, if it isn't done properly, you could have a gap there. So there is a lot of dependency between systems. It's a matter of identifying and understanding that. So we look at one of the projects, we look at all the different systems and how they're all interfacing with each other and the dependencies between them, and understanding those and how they interact with each other. So again, each of these systems might be in different safety or different critical zone or security zones, but they're interacting with multiple other ones in other zones. And how do we monitor that, control that, and how they interact? So this picture is slightly blurred because it won't give too much details, but I think you would get the idea of the complexity. I'd like to pause here in case anyone has any comments or questions. And please, if you have any comments as we go, put them in the chat. I'll try to respond back or put your hand up. So if I'm going too quick, let me know. If you have some comments, we can sort of pause and discuss it a bit. I'd like to have that as a bit of an interactive seminar if possible. So when we look at cybersecurity, it's a matter of it's a number of the controls that we would have. We always talk about, we usually have technical and non-technical controls. So technical controls could be like we have firewalls, we have an Active Directory to monitor people's access controls to systems. We have logical access between systems. You know, how we monitor the systems for auditing purposes. All those technicals, patch management, those are more technical controls. And there will usually be policies and procedures that go with it that says what we need to do, why we're doing it, etc. And then we have those non-technical controls were essentially the policies and procedures that will call out the policies that will call out the technical controls. And those as a combination will put together our cybersecurity program. And then on the side there, we would have physical security. So some of the security that we use for cyber is that your cyber asset, depending how you defined it, is in a lock controlled room. So how do you access those controls? Again, with certain systems, let's say traction power substations, a lot of it is if there is a problem, the people that have access to the room want to be able to, you know, basically disconnect a large switchgear. We can do it both using electronic means, we can use it physically. So the question is, do we put cybersecurity on it? Someone has to log in with a password in order to shut something down, or they just go in the room and they basically pull the plug or pull the switch, right? And it has to be according to the project and how you do it. So on those systems, you're relying heavily on your physical security, how people gain access to that equipment. And that's usually sometimes the way when we say we have multi-factor, one of those factors would be you need to securely access the room in order to securely access the system. So when we look at where we go for guidance for these controls, obviously APTA within their documentation, they're laying out, you know, a number of controls. The issue with APTA, it's recommendations, and some of it aren't explicit enough to work on. So we look at other controls then to help clarify what we would need to do. And a lot of times, you know, most organizations will look at the NIST sort of standards, and NIST has, I would say, 30 or 40 documents. They can be quite long, 300-400 pages, and understanding how to read it. And that's why APTA was trying to make it for an organization, rather than going and trying to distill it out of the NIST documents, they gave them guidance to it. But within NIST, the NIST 853 is oriented to industrial controls. There's about 18 families there. There's actually over 200 individual controls, and how you apply that and which ones you select as would be appropriate to the project and what you're looking to do. And you can look at additional controls, generally a TVA threat vulnerability assessment. Again, going back to risk, doing your risk analysis and saying what risk level is acceptable to your stakeholders, to the governance structure. And if they're still, the risk is too high, then you look at additional controls to mitigate those risks. As an example, these are the high level family. This is the NIST controls. You know, I would pull out just a couple. I don't want to go through all of them, but is it personnel security? Are the people working on your project, you know, have you vetted them? Are they the right people? If they're accessing sensitive information, you know, do they have the right controls to it? So one of the controls is, how do you do that? How do you approve? How often do you review your personnel? And it's not only for your own personnel, it could be for your supply chain. Do you have subcontractors that are on site doing work? Are they properly screened also? Electronic and physical access management. This is both for the physical. So do you have access control to get into where you have your cyber assets? And then you also have proper managing your assets. It's like we all have IT computers and how that works. And we all know that, you know, logging in, changing passwords, etc., and what you're allowed to do on your computer or not. Similar that we do the same for the cyber assets on the project. Other areas of main concern is cyber incident response. So you've identified a problem. Who's going to respond to it? How do you respond to it? Whether it's just a cyber incident or it could be full malware. And you need to have a full cyber incident response plan in place and how you follow that. So again, these NIST documents, set of documents, give you direction how to respond, how to put that into place. And again, it's based on your risk and the organization itself. I'd like to, just the other one, I'd like to put supply chain management. What we've seen on one of the projects, that the organization is adopting a supply chain management, and they're asking all their suppliers to meet it. And it's fairly onerous in what they're asking. And they're assisting their vendors, their existing vendors that are already supplying equipment, because they will need to meet it. They will go through an audit process. So the question, this specific organization is assisting with their vendor to understand what their requirements are, how to meet it, and identifying it and make sure they will be able to meet it. So understanding that it's not just within the organization, it extends out to your organization, especially if you're sharing confidential information with them. They're providing you confidential information how your system works. So it's a shared responsibility. So again, most of this information is readily available. NIST, as I'm saying, has some very good frameworks and how you follow it. They have very good controls. They're not the only ones. There are other organizations and frameworks out there, such as ISO, but it's a matter of selecting what's appropriate. You know, key, when we talk about putting together cybersecurity, it's about the program itself. You have to have a program, how you're going to implement what's important, how you're going to manage it, and, you know, putting that program together. So these are just some of the domains we would say. I would say, you know, the management side at the top, risk management, what risk management, you know, program or framework would you follow? What is important? How do you calculate risk? What's agreed to, and what risk level you're willing to assume? Asset management, config management. You know, do you have a config management and asset change management process in place? And how is that? And again, all of these have to be auditable. Identity and access management. I'm not going to read through all of them, but I'm just pointing out some of the more important ones here. Workforce management. On projects, you know, we have a cybersecurity awareness training program that the staff needs to go through. We audit that. They have ongoing cyber awareness. I think most companies now have it, but this is specific to the operational side. How do we share information securely is very important, because there are a lot of confidential documents that are there, such as how we set up passwords, the network design, etc. That is considered cyber sensitive, and in how you share that information and you track it is very important. Skip to slide. For an organization, it's very important to understand what their maturity level is and what they would like to accomplish. What we've looked at a lot of new projects, you know, to get a maturity level of, let's say, 3, it's great, but realize your staff have to be trained, you have to be aware of all the equipment. So it's a plan how to get to a level and where you plan on being. Generally, what we're looking at for a greenfield, what we're looking at is a realistic target of being between a mil 1 and a mil 2. So understanding what that means, but it's not only having the equipment in place, we talk about cyber, it's people, processes, and technology. And all 3 have to be in place. You need to have the controls in place. You have to have everyone trained. You have to have the audit trail. So it's a matter of having all that to be able to say you have a certain cyber maturity level. And what is attainable in the short term versus long term. What we're saying is you bring these projects in, it has to be realistic. This is sort of a chart we've used, but it applies more to a greenfield, but it applies just as well for an operational. So again, where you're starting at, what are the controls? So select them early, whether it's, you know, you're starting to design a project or you're already an operational entity. What are the controls? How do you apply them? Create a program. And then based on that, you come up with your baseline controls. So what are the controls? At that point, you can then say, okay, we're going to do a vulnerability assessment on what we already have. Say, these are our controls. Do we have what our risk level is? Do we need additional mitigating controls? How that plays into the overall plan or the program within the cybersecurity. What are the dates? So setting targets. whether it's your existing operational and where you are and where you want to go to mill and what, you know, the schedule would be over a number of years, or if it's a greenfield project, where you are within the construction phase of that project, the handover, etc. So what would be the date when you're handing over on a construction phase to, let's say, the maintainer and the operator? How do you hand that over? What are you handing over, and the records that go with it and the overall program? What happens in between? So again, on a greenfield, what happens between the handover and actually going to revenue service and commissioning? Because as we all know, as we build these projects, the systems take time. They come up over a period of time. We're adding, we find configuration. So you might have one system that's up early on, maybe the network, because basically most of the other systems can't operate without it. So what is the program and how do you put that into place? Again, the same thing if you're an operational. As you changing and updating it, how are you modifying it and how your program changes over that time? And then what's your assurance checks? Do you have an independent party come and do an evaluation? Do they come in and do they do an independent threat vulnerability assessment? Do they do a penetration testing? Depending on the program, how you're going to set up to say, do you do it internally, externally, or both, to say that we're meeting the targets that we've set out, and when we reevaluate the risk, are we meeting that risk that we talked about? And then the turnover, whether it's to commercial or it's just ongoing. So what is that state? And then basically the cycle starts over, because it's as you do it, you're continually evaluating it and improving, because the threats, they change, as we all know. So again, what level of risk, again, are you willing to assume? Has the threat environment changed, and how do we adapt to it? So sort of the steps to going through it, whether an operating or new project, you know, you have to identify your cyber assets. You have to understand the governance structure you're working under, and who is the ultimate assuming the risk, where is the risk end, and what the risk level, risk appetite is. Perform a threat and vulnerability assessment. There's good frameworks out there to follow. So, you know, there's companies that do that, there's standards you meet, there's frameworks to meet. Then based on that, you implement your program. So, and that includes both budgeting timelines, because a lot of it is, you're not going to do it overnight. Generally, we're looking at one project. We have like a 5-year sort of timeline, how we bring it up, where we want to sort of be in 5 years from now, and the sustainable without that. And then it's a matter of training your organization where you are within it. And make sure cybersecurity, it's just not 1 or 2 people, it's within the whole organization. And also it's within your procurement. So again, supply chain. Example is a lot of cyber they've seen in industrial controls that has come through the supply chain. It's a technician bringing a laptop, configuring something on site and introducing a virus within it, or misconfiguring something. So when you go into operation, that's been latent there, and you don't find it for several years later. So the supply chain and the procurement is very important as part of your overall cybersecurity program. And what we say is it's ongoing. It's a review, iterate, and basically go through the cycle again. So it's always going through this constant cycle of reviewing, auditing, improving, risk analysis, monitoring, etc. And that essentially brings me to the end. So it's really a matter of understanding the environment, the operating environment you're working within, the risk level that you're willing to, the appetite you have, and then how do you work along and initiate it within the project. It can't be standalone. It has to be part of the overall organization and project development. With that, I'll leave it open to questions. Thank you.
Thank you very, very much, Michael, for this presentation. If anybody has a question, you can type it in. I've received one by email that I can start with while everybody puts their questions in the chat. So this is coming from Montreal. This Mark from Montreal says, with regards to the NIST controls mentioned, is there a priority list for how the controls are implemented? For example, is there a specific order one has to go in?
NIST doesn't really give you that, and a lot of the project is how you apply it. And I guess there's two issues. It's understanding the risk, understanding your assets, your systems, right? So when you look at which systems you have, you would apply, the controls apply across everything. It's a matter of what can be implemented and what's higher risk and which ones you're going to apply first. So we're working on one project now, and they have certain, let's say, technical capabilities that they have available. So just to start off, we're saying what is, well, I'll call it low-hanging fruit. So what we're saying is based on all the controls. Some of them is identifying all your assets to start with, because if you don't understand your assets, you don't know where to start. So understanding that is one of the first steps. One of the other steps, we do know some of it is, we know some of the systems haven't been patched in a while. So we're looking at some of those assets, let's say the more critical ones, and we're working out a program to start with that. So it doesn't give you that guideline. APTA sort of helps, but you really have to go back and evaluate it and see what you have and what you can do in the short term versus long term. Now, I would say it's following in parallel. Develop a program as you're actually implementing some of the controls that you could select. It might be as simple as access control, making sure where your assets are, they are controlled access into those facilities or access to log into those systems. But it's more individual. I hope that helps a bit.
This was submitted by email, someone who had to leave, but they wanted this to be on the record. So if anybody has another question, you can raise your hand right now. Okay. So I got a private message. Can you discuss how you are seeing cyber become more relevant to supply chain requirements, vendors, etc., in the transit space?
So yeah, so it really depends on the vendor. So generally, like what we've seen so far, we're working with certain vendors that are more network centric, I'll call them. So they understand it, that as part of their supply, they have to meet the cyber requirements for the project. So a lot of it is about integrating their systems. If they're integrating within the project, in some projects we have common controls, sets of, let's say, an Active Directory, patch management, backup and recovery, whatever, and other ones don't. But if that's part of it, then it becomes part of that program. There's also other areas within that program, depending on what they're delivering, what systems they're doing. Their maintenance technicians follow the procedures. Their maintenance people are all vetted as far as security. There's also, for following systems engineering management plan, their software, depending what it is, how they're showing their software and their development cycle is secure, how they're keeping it secure. So it could be quite broad. If it's some vendor that is, let's say, supplying something that would not normally consider what we would consider a cyber asset, it could also be, part of it is they're getting confidential information that they're exchanging, and in how they are handling that confidential information, how they have access to it, how they keep it secure, etc. So it really depends on what the vendor is doing, what supply is, whether it's an active system that system they're supplying meets cyber, or whether it's let's say a non-conventional, but we wouldn't consider a cyber asset, but because of the project they still need to meet all the supply chain requirements for that and how they identify it. And the other thing is we're seeing now with some of, especially let's say US, Canada, we're a little behind, but I think it's going to come, that they are now starting to follow and push out that they do need to follow like some standards now.
Okay, I have a question, Andrea, if you don't mind, and Michael.
Please.
So cybersecurity seems like a daunting task. On a level scale of from 1 to 10, what's the what is the level of difficulty to start the cybersecurity on a project, on a green project and brownfield one?
So okay, so if I understand that for what you're asking, like generally we say cyber sort of follows, like I think most of us are familiar with systems engineering approach. So cyber is generally within the project right at the beginning, right? You understand the systems, you understand how cyber will play in, and generally what we've done is we've created a cybersecurity management plan, just like you've created other management plans for the whole project on greenfield, and how we follow it through, because it should be, you know, part of the initial specifications, the procurement specs, etc. When we're talking about, let's say, a brownfield, and I guess I'll separate brownfield between an extension to an existing versus a existing operational. So a brownfield, part of the issues with brownfields is the cyber requirements for the brownfield might be more descriptive and required than what actually, when you're connecting to an existing system, the existing systems might not be capable of meeting that. So a lot of times, if we're meeting some new standards, the existing systems have to be upgraded. So you have to go through the whole review and work out with the existing systems, are they going to meet it or not, and what are those requirements with whether it's an existing operator and what their cyber requirements are. So it depends on, we've seen language in project agreements that the extensions have cyber requirements, but the existing don't sort of meet the same, and we have to get those aligned at the very beginning.
Okay, and before I go to the next question, there is somebody who has a question. If you don't mind, Michael. So today, maybe we start with the green project, but in the future things will upgrade naturally, right? So do we take provision for this, like especially from the hardware part? Because at some point, I mean, you're going to use fiber optic communication cables, but in 10 years, maybe you will need a different, do we take a provision now, or we don't know what's going to happen in the next 10 years, 15 years, and we do what we do with what we have today?
Yeah, so from a strictly cyber perspective, right, the communications link, whatever, is more physical, but depends how they're doing it, how they're interconnecting, you know, whether we're using cloud-based, whatever. So it's a matter of the security and the controls are there, it's evolving. The threat sort of evolving. You know, what I've seen is we used to buy, you know, SCADA systems, they buy a system, they expect it to last 30 years. That doesn't really happen anymore because the underlying hardware changes, the operating systems change. So we know we're going to have to adapt. And how do we build that in? The controls generally stay the same, or the controls change depending on the risk level and the threats and the threat actors type thing, right? So we know now that cyber is constantly evolving, and the project have to plan on that, and they have to do continual auditing and upgrading as they go. As far as you say, physical communication, honestly, I have no idea what they're going to be using, but we know they're going to communicate and how we secure that and what the requirements are for it, right?
Yeah.
You know, it's one thing I think we all know now, things have evolved a lot faster and it will switch. So where, you know, you used to buy a train that would last 50 years, right? And they'll do a refresh. What we know is there are a lot more electronics on those vehicles. And how do we secure that, right? And it's difficult to do that, but we can plan for it, at least, you know, looking backwards and, you know, with some assessment. So I think the one constant is it's going to change. We got to build that into the plan, essentially.
Okay, thank you, Michael. Andrea, I think we have another question, huh?
Yes, we actually have two more questions. Med here is asking, do we have classes or levels in cybersecurity systems or protection compared to the SIL levels, for example, in railway systems?
It's not the same, but what we're saying is the criticality. So the issue, if you have like a SIL 2 or SIL 3 or SIL 4 system, right, you might put that in a different zone. So let's say we say a SIL 4, which is typically, you know, a signal and train control, within the vital system, right? Non-vital is usually not a SIL SIL 4, but it's connected. So the issue is with cyber, we're going to say that's a critical, and how do we apply and what's the risk? So then we evaluate the risk, generally the integrity and the availability of those systems, and then how do we secure it accordingly, okay? And so we would look at the SIL level and say the criticality based on the SIL, and we apply the cyber based on a risk. So it doesn't apply the same, but we're looking at it as risk. So obviously where you have the highest risk is where you're going to mitigate those, put the controls in to mitigate those to something acceptable.
That's great. Matt, if you have any follow-up to that, you can type it in. You can raise your hand as well. I'm going to give you a moment. And he has another question that he typed in. More of personal question. Do we need a solid IT or computer engineering background to work as cybersecurity assessor or auditor?
In some ways, I would say it helps, but not necessarily. If you're going to do audit in that, if you understand risk assessment and how to do it and follow the process, understand it, you can follow it. At some point, yes, you have to understand the systems themselves, but generally to do, let's say, like a risk assessment, understanding that process and having someone else that would help within it, that would help. But I think it's a combination. So if you're saying you don't have that electronic background, like networking, you can take the courses, learn that, but it's more understanding the process of risk assessment. And risk assessment is similar to in other environments also, and how you calculate and that methodology behind it.
Very well. So Matt says here, thanks very much for the useful presentation and answers. If anyone has any further questions, please, you can ask them now. We will also be sharing with everyone Michael's contact for you to connect outside of this webinar. Michael, I have to say it's been really enlightening and really thorough. I want to thank you from TRACCS for your role here today. And there's another question.
Yeah, there is another question, Andrea.
You're not off the hook yet. So Obrad Alexic is asking, in your opinion, how much are the TS 5701 and IEC 62443 standards applied in transit?
Oh, right. Okay, so what I understand, 62443 is one that the European just sort of brought out and adopting. They're looking at it because of if I'm trying to remember the standard. They're looking to implement it now, and it's like early on is part of what they knew. And if I'm trying to remember what systems it applies to, I don't think it's everything yet. I think it's more the signaling, if I remember correctly. I'll have to look it up. Like a lot of these standards, the issue is in North America, let's say mass transit, the APTA, those organizations haven't adopted, we don't have it. US is pushing their critical infrastructure. I think we know what they're looking to do with cyber. There is no real standard yet that they're saying we have to meet. There's no regulatory. Europe is ahead of us. I can see that coming or something similar, whether we adopt it here, but I can see eventually that we will have a regulatory framework of what the organizations will have to meet. Canada, I can say we're probably a number of years out. What I've seen is we'll follow US later. I think the US, just because they have the funding, they'll start with it earlier. And I think the 62443 is probably where gives us some background where to follow. It's not complete, but it's at least a starting point.
So, Brad, I don't know if that answers your question. Oh, there he says, thanks. Very well.
I'm just going to say it's evolving. And I know we're talking with some European agencies and they're looking to, how they're going to adopt it. So it's coming, it's just over time. I think the regulatory framework is whoever's going to step up, they have to provide funding to it also, is one of the biggest problems.
So I have a question that I just thought of from what you're saying. We all know that in Canada there are no national standards that we can apply. And so, Michael, do you see standards in Canada happening as a cooperative effort from the level of professionals creating it and submitting it for government, or do you see that as the responsibility of the government, perhaps?
I think the government says they need it and how they develop it. Like in the US, they have NIST, the European, they have these EN standards. There's also IEEE standards we could follow. I think my personal feeling, it should be combined. APTA try put these recommendations just so there's agencies, small bus agencies that have to do cyber and they have 2 people versus, let's say, an MTA that has probably 30, 40 people alone in their cyber group, right? So it's a matter of, I think, both government and the private sector, the engineering sector, with whatever those groups are working together to develop some sort of framework and standards that can be applied.
Very good. And the follow-up question to that is, would you be open to cooperating on that aspect?
Absolutely. We have a couple of people sitting on APTA cybersecurity now. One of our people, I think he is a cybersecurity expert. He does sit on some different committees and things. So there are committees. I think just like a lot of the standards, the way they get developed, I think it'd be important. It's combined. The operators, maintainers. I think all of us should be part of this because we don't want them pushing something down that's unattainable. And as I said, is if the government's involved with industry, who's going to help fund it?
Yeah.
Right. So a lot of the agencies, their budgets, we all know, are strapped. They have other problems. How are we going to bring this in? We all know it's a problem, but how do we fund it? Should also be part of that.
That's true. Well, this line of questions and this conversation, it just so happens that at TRACCS, we are starting to look for partners in working towards the national standards. We are having meetings with other stakeholders, and so I think we're going to be calling on you, Michael.
Very happy to do that. The way a lot of them work is they do task forces, right? They set it up. They again, the governance, we give them some scope of work, what to do, and we set up there's other terms for it, the task force. I know IEEE has, there are other terms for it, but essentially that's what you do to start developing, like a white paper on it. And yeah, I think it would be a very good approach because it doesn't seem like anyone else is doing it.
Very well. Well, thank you very much. If anyone has another question, this is the last moment where we're coming to the end of today's webinar. Nafa, yeah.
If we finish with question and with Michael, thank you very much, Michael. It was really a good presentation, and cybersecurity is more and more required and important, not only in transit rail but in all the other projects. Andrea, if we have some more time, can we go back and present what we have upcoming for the audience, so we can some people join later, so they couldn't maybe see what we got.
Very well. So first, again, thank you. And I wanted to leave everyone with your contact information, Michael Godfrey. So if anyone wants to connect with Michael, it's michael.godfrey@wgdconsulting.com. You can email him about further projects if you have more questions, or if you want to share this presentation internally in your companies. And as you said, Nafa, we do have some other events coming up. The next webinar that we are hosting is in just a few days, April 20th. At noon, like today. It's called Data from Trees to Tracks. Summit Infrastructure will join us in speaking about how utilizing data can keep the boots off the ballast and drive efficiency and save money, which are, of course, important aspects of any project. So be sure to register at TRACCS.ca, and we will host this webinar on April 20th. As we said earlier, Rail Day is coming up. We have several components to Rail Day today. This year, we have grown from the one space that we had last year to the International Center in Mississauga. So we will have indoor and outdoor components. There will be demos. There will be 3 rooms with all-day conferences happening both days. And we will have a cocktail. There will be some other surprises coming up, and we are still taking some presentations. If someone wants to become a speaker, that's also a possibility. Please make sure that you connect with our team. You can email me, Andrea r@traccs.ca or info@traccs.ca. And then this exclusive event for TRACCS members, the Canadian Transit Rail Delegation to the Czech Republic. We are really happy that we're finally making this happen. We're inviting you to join the Canadian Transit Agency delegates on a tour of the transit rail operations in the Czech Republic. The tour will include introductions to agencies, government officials, technical tours of rail operations, and introductions to local and international Czech vendors. We will be meeting with the Ministry of Transport, Prague Public Transit Company, Pilsen City Transport Company, Ostrava City Transit. There's also, in that week, this is going to be June 4. In that week of June 4, there is a trade show happening in Ostrava. So that will be part of the tour. And the spots are limited. This is an exclusive opportunity. And it includes, for $4,000, includes meals, the local transport, and the accommodations. So please contact Jen Wyszynski at jenb@traccs.ca. And again, thank you very much, everyone, for being here. And Michael and your WGD team for this great presentation.
Thank you very much, Michael. Thank you, Andrea. Thank you, everyone.
Thank you.
Have a great rest of your day, and happy Easter and happy Passover if you celebrate.
Yeah, don't eat too much chocolate, huh? All right, have a great day. Bye.
Thank you. Bye.
Thank you very much. Bye now.